Presentation on constant velocity for Lab 1. My name is Samantha Nizema. Thank you for tuning in. It's supposed to go to the next slide. My bad. Okay, so today in my presentation, I'm going to be discussing the purpose of the experiment, as well as the procedures that I took and the physics principles involved in them. And then I'm also going to be looking at the data and analyzing it and just giving you a conclusion on what I found, and also answering some questions about if different things happened within the experiment and how the experiment would be impacted. So let's talk about this lab. So in this lab, we are analyzing an object moving at a constant velocity and comparing it to the expected position that the computational model flow script calculated. And the purpose of this is for us as students to better understand Newton's second law and to just observe something that we have been focusing on in class. What is Newton's second law? So Newton's second law surrounds the idea of how forces can influence a system's momentum to change over time. And there are different equations for that. There's one equation for it, but there's different parts to it. And right here we see the velocity being impacted and being noted. And if you see in the final equation, you see that this represents the velocity update formula, which is a part of the Newton's second law. So we are looking at we look at the initial velocity and the final velocity that is shown over here. And this is just, all this looks like laid out row by row. So let's talk about the experiment. How did we do this? So for me, I used a foosball ball, and I rolled it across the floor in a straight line at a constant speed. And I then, uploaded this video to uh, Tracker to track the position of the ball. And I created a computational model by editing the starter code that we were given. And then I created a spreadsheet comparing the observed and predicted positions of the ball and documented my certain observations, and this was put into a graph that we will see soon. So here is my graph. This is me tracking it. The blue that is on there right now, that just was me playing around with this tracker thing. So that's why there's blue there. That was just another mass that I was practicing with. But if you look at the red, that's what we are analyzing right now. And that's my little brother pushing the foosball ball. And for my point of reference, I used a pool table stick. Yeah, that's what it is. So let's look at the tracker outcome. So this was the starting position, and the total amount of time that it took was about 1.8 seconds. And if you look at the R hat, the R hat would be this value over here after doing some calculations, and then that would be the initial velocity as well. So those were the initial position and velocity. Afterwards, we can look at the computational model. I just inputted the values that I got from the graph in Tracker, and change the code here so that I could create the model to match what I had just observed previously. And I changed the while loop. I made it 1.8 seconds because it was approximately 1.8 seconds. And then on top of that, I changed the vectors to match what I had found originally. So here's my graph, and you can see that it's quite similar what was predicted and observed, but of course it's not the same. So that's what we see over here. So some possible errors. Let's talk about the environment. The fan was on when I did this. So boom, the fan could have